Look, I got a nice big canvas. I'm going to make a tent and go camping.
Nice.
Hey, I got to get tent poles, though. Can you help me figure out how to make my tent as big as possible?
Why don't you ask Dr. Buell for help?
I already tried that, but his eyes just kind of rolled back in his head, and he kept mumbling, think for yourself, over and over and over, and then he started kind of tugging at his hair. It was sad.
Oh. All right, well, I guess I can help you. And luckily for you, I actually have an example that we use. See this piece of paper? You can either fold it in two different ways. You can fold it like the hot dog way, like this.
That's cool.
Or you can fold it like the hamburger way.
So what way is bigger?
We're going to have to use math to figure that one out.
All right.
For the fun part, I will be constructing a pup tent in Sketchpad with our canvas of 11 by 8.5 feet. And since we are constructing this in Sketchpad, the units will be in centimeters instead of feet. So here we go. As you can see, I have started with 3 lengths already, as you can see. The slant length, the pup tent length, and the height. These 3 will be used to construct our pup tent. And there's also a point right here, and this will be our starting point. From here, I will select this and the height and construct a circle by center radius. I will now select this and draw a line to the top of our circle. Now, I will select the center point again and construct a perpendicular line to that line. This will be the basis for our ground of our pup tent. And now I select the very top of this, and I'm going to select the slant length. This will allow me to construct a circle by center radius and have intersection points on our ground. Now I'm going to select this and make intersection points. Drawing this line from the top of our first circle to the slant length intersections will create our slant lengths of our original triangle, of our front of our pup tent. Now I will select this and our pup tent length. Now I'll construct a new circle. Using this, I'm going to draw this out and create the length of our pup tent. Following the same thing, I'm going to do that and this and create a parallel line. Now, when I select this and this, I will make a new circle, and that intersection point will be the point of intersection for our same length of our pup tent. Connecting these will be parallel to our original slant length. From then on, I'm going to choose this point right here and construct a circle with our slant length height. Next, choosing this parallel line and this point right here, I will construct a new parallel line. With our new circle that we have just constructed and this parallel line, this should be our intersection point for our back end of our pup tent. Selecting this and connecting it. Connect these. Connect this. Connect this. Our pup tent should now be complete. I'm going to select this and Control Alt. And then hide them. Now I'll select our lines that we've created before and hide these as well. Our pup tent should be finished. And just check if it works. It works. Our pup tent is complete.
First, we need to find an equation for the volume of the tent. Volume equals 1/2 base times height times length. We recognize the area of the surface at the end of the tent as the triangle 1/2 base times height. We can use our old friend the Pythagorean theorem to discover the relationship between the height and the base of our tent. Remember, the slant length is given by the size of our canvas. Express B in terms of h. Now we can substitute the new expression for B into the volume equation. Since the slant length and the length are givens, the formula has only one unknown, h. Here is our volume formula using actual canvas measurements for both the hamburger and the hot dog configuration. To find the maximum volume in each case, take the derivative of the volume and set it equal to 0. This allows us to solve for h, the tent pole height that maximizes the volume of each tent. By substituting the height back into the formula, we can see that the hamburger version has a larger volume. Calculus to the rescue once again. The solution that we discovered using calculus is confirmed by our graphical solution. Once again, the hamburger-style tent is bigger. Let's animate Sketchpad and watch our volume change.